For today, we will be discussing Module 8, which is about metals. This chapter primarily presents the different types of ferrous and non-ferrous metals. This chapter provides the overview of some of the commercial alloys and their general properties and limitations. Material selection decisions may also be influenced by the ease with which metal alloys may be formed or manufactured into useful components. Alloy properties can be altered by fabrication processes, and in addition, further property alterations may be induced by the employment of appropriate heat treatments. This chapter also discusses the details of some of these treatments, including annealing procedures, the heat treating of steels, and precipitation hardening. Metals are present everywhere around us and are one of the major materials upon which our economies are built. Metals form about a quarter of the Earth's crust based on weight. It is one of the earliest material that is used back in the prehistoric time. Metals is a material that is typically hard, opaque, shiny, and has good electrical and thermal conductivity. It is also generally malleable, whereas they can be hammered or pressed without breaking or cracking. It is also fusible, which means that they are able to be fused or melted, and is also ductile, wherein they are able to be drawn out into a thin wire. In this figure, we have the classification of the various ferrous alloys. The metal alloy is classified into two categories, the ferrous and non-ferrous alloys. Kapag ferrous, ibig sabihin ito ay iron-based, and kapag naman non-ferrous, it indicates the rest of the metallic alloys. Kaya po na-classify ang metal alloys into two categories na nakabase sa iron ay dahil ang iron ay ang pinakaginagamit sa metallic systems. Ginagamit din ang iron in many applications and is readily available sa Earth's crust. Ferrous alloys is then divided into steels and cast irons, whereas meron silang classifications under it. Ferrous alloys. In the ferrous alloys, meron itong main constituent, which is the iron. And the iron element is yung reason kung bakit ang ferrous alloys ay durable and is known for their tensile strength. They also have magnetic properties, kaya naman ginagamit ang ferrous alloys sa paggawa ng mga motors and electrical appliances. In addition, dahil sa mataas na amount ng carbon na nasa ferrous alloys, most ferrous metals and alloys are vulnerable to rust, especially when they are exposed, lalo na sa water. Although, this isn't the case with wrought iron or stainless steel. Napoproduce din ang mga ferrous alloys in large quantities, whereas they are especially important and is widely used in the field of engineering. Their widespread use is accounted for by three factors. First, iron-containing compounds exist in abundant quantities within the Earth's crust. Second, we can produce metallic iron and steel alloys through some processes and techniques such as using relatively economical extraction, refining, alloying, and fabrication techniques. Third, since ferrous alloys are extremely versatile, they can be adjusted, modified, or altered depending on the mechanical and physical properties that a certain ferrous alloy must have. Steels are hard, strong, gray or bluish-gray alloys of iron with carbon and usually contains other elements that is used extensively as a structural and fabricating material. Some mechanical properties are sensitive to the content of carbon, kaya naman ang normal weighted percentage lang ng carbon ay less than 1. Yung plain carbons, nagko-contain lang sila ng carbon and a small amount of manganese. So, as said earlier, there are some conditions wherein other alloying elements are added to alloy steels. Some of the more common steels are classified according to carbon concentration, namely low carbon, medium carbon, and high carbon types. Subclasses also exist within each group according to the concentration of other alloying elements. In this figure, we have the steel numbering system. In the steel numbering system, may two major numbering systems na ginagamit ng steel industry. The first, developed by the American Iron and Steel Institute, or AISI, and the second by the Society of Automotive Engineers, or SAE. Parehas yung systems na naka-based on 4-digit code numbers when identifying yung base carbon and alloy steels. Meron din naman na ibang selection ng alloys na naka-based sa 5-digit codes. Looking at the figure, we have 4-digit code numbers. The first and second digit indicates the type of material. In the third and fourth digit, it indicates the amount of carbon in the steel. If the first digit is a 1, it indicates a carbon steel. All carbon steels are in this group in both the SAE and AISI system. They are also subdivided into 4 categories due to particular underlying properties among them. Plain carbon steel is encompassed with the 10XX series containing 1% magnesium maximum. Resulfurized carbon steel is encompassed within the 11XX series. Resulfurized and raw phosphorized carbon steel is encompassed within the 12XX series. Non-resulfurized high manganese is up to 1.65 weighted percentage. Carbon steel is encompassed within the 15XX series. For other alloy steels, the first digit on all other alloy steels, that is under the SAE, AISI system, are then classified as follows. For 2, it is the nickel steels. 3, nickel chromium steels. 4, molybdenum steels. 5, chromium steels. 6, chromium vanadium steels. 7, tungsten chromium steels. 8, nickel chromium molybdenum steels. 9, silicon manganese steels, and various other SAE grades. The second digit of the series indicates the concentration of the major element in percentiles. Kapag 1 ang nakalagay, ibig sabihin equal sa 1%. The last two digits of the series indicate the carbon concentration to 0.01%. So, given for example the SAE 5130, it is a chromium alloy steel given that it is a 5, containing about 1% of chromium because the second digit is a 1 and approximately 0.30% of carbon. Low carbon steels. We characterized low carbon steels by its low ratio of carbon to iron. Kilala din ito bilang mild steel and isa siya sa largest groups of carbon steel and is most widely used in the industry. Low carbon steels contain less than 0.25% carbon. They cannot be hardened by heat treatment to form martensite. kaya naman na-achieve siya by cold work. Carbon steels are usually relatively soft and have low strength, pero they have high ductility, kaya naman excellent siya gamitin for machining, welding, and it is also low cost. The typical applications include automobile body components, structural shapes such as I-beams, channel and angle iron, and sheets that are used in pipelines, buildings, bridges, and tin cans. So here, we have a type of low-carbon steel, which is the SAE AISI 1020. It is a very machining-friendly steel dahil sa mababang carbon content. Madali din siyang i-weld and pwedeng gamitin sa mga machining processes such as drilling, milling, and turning. This makes it suitable for use in a wide variety of general engineering uses. Its common uses include light-duty gears, camshafts, cold-headed bolts, and general engineering parts and machinery. High-strength, low-alloy HSLA steels. The high-strength, low-alloy steel or HSLA is a type of alloy steel that provides better mechanical properties. Mas mataas yung resistance ng HSLA sa corrosion compared sa low-carbon steel. HSLA steels vary from other steels in that they are not made to meet a specific chemical composition but rather specific mechanical properties. It also contains alloying elements such as copper, vanadium, nickel, and molybdenum in combined concentrations of less than 10 weighted percentage. Dahil small amount lang ng carbon ang nasa HSLA, they are much or twice stronger than plain low-carbon steels. They are also ductile, formable, and machinable. The tables 2 and 3 present the compositions and mechanical properties of several plain low-carbon steels. In the AISI SAE 1010, 10 ang first and second digit kasi as indicated, it is a plain low-carbon steel na nagko-contain ng 1% magnesium maximum and 10 ang third and fourth digit kasi naka-indicate na it has 10% amount ng carbon. In the A36, a minimum of 0.20% copper ang idinagdag to improve its corrosion resistance sa damp or humid conditions. In that case, the ASTM A36 steel is the typical low-alloy steel or copper steel. These alloying elements are added to give A36 steel its desired chemical and mechanical properties. As we can see, mapapansin din agad na yung HSLA steels are much stronger than the plain low-carbon steels as they contain other compositions which improves the mechanical properties of the steels. So in this table, we have the equivalent applications of the given steels and also naka-indicate na din yung tensile strength, yield strength, and ductility nila. In average, the given steels typically have a yield strength of 275 megapascal, tensile strengths between 415 and 550 megapascal, and a ductility of 25%. Looking at the table, we can see that a higher strength and a higher yield strength And lower ductility means that the type of steel is strong, whereas makikita natin na yung application na truck frames and railway cars is located in the lowest part. Mostly, ang ginagamit na material to construct vehicle chassis and frames is carbon steel. The truck frames and railway cars uses high-strength low-alloy steel to achieve a more lightweight construction. Medium carbon steels. Medium carbon steel has a carbon content of 0.25 to 0.60 weighted percentage and a manganese content of 0.60 to 1.65 weighted percentage. It is stronger than low carbon steels but less ductile and less tough. The mechanical properties of this steel are improved via heat treatment involving austenitizing, followed by quenching and tempering, giving them a martensitic microstructure. Heat treatment can only be performed on very thin sections. However, additional alloying elements such as chromium, molybdenum, and nickel can be added to improve the steel's ability to be heat treated and thus hardened. Hardened medium carbon steels have greater strength than low carbon steels. However, this comes at the expense of ductility and toughness. Ginagamit ang medium carbon steel sa mga railway wheels and trucks, gears, crankshafts, and other machine parts. High carbon steel. High carbon steel has a carbon content of 0.60 to 1.4 weighted percentage and a manganese content of 0.30 to 0.90 weighted percentage. It has the highest hardness and toughness of the carbon steels and the lowest ductility. High carbon steels are very wear resistant as a result of the fact that they are almost always hardened and tempered. Tool steels and die steels are types of high carbon steels which contain additional alloying elements including chromium, vanadium, molybdenum, and tungsten. The addition of these elements results in the very hard wear-resistant steel, which is a result of the formation of carbide compounds such as tungsten carbide. Ginagamit naman ang mga high carbon steels sa mga cutting tools like knives, razors, hacksaw, blades, and many more. Stainless steels. The stainless steels are also widely used especially sa mga kitchens, surgical tools, and also medical equipment, and even sa mga automotive aerospace applications. With a minimum chromium content of 11%, ang stainless steel is napoprotect ng mga passive layer ng chromium oxide that forms naturally on the surface through the reaction of the chromium with oxygen from air or water. So, kapag yung surface of the stainless steel is scratched, it regenerates itself. So, this is what makes the stainless steels highly resistant to corrosion. Stainless steel combines ductility, elasticity, and hardness, enabling it to be used in difficult metal forming modes like flat bending and extrusion, while offering resistance to heavy wear such as the friction, abrasion, impact, and elasticity. Furthermore, meron siyang good mechanical behavior parehas sa low and high temperatures. The categories are based on their structure, the martensitic, ferritic, and austenitic. So the first is the martensitic stainless steels. The martensitic stainless steels is capable of being heated in such a way that martensite is the prime microconstituent. Ginagamit ang martensitic stainless steels sa mga cutlery, cookwork, surgical and dental instruments, and many more. So, it is also durable, has high strength, and resistant din siya sa corrosion. We have a type of martensitic stainless steel which is the grade 410 stainless steel. Ito yung pinaka-ginagamit na martensitic stainless steel and is the general purpose martensitic stainless steels containing 11.5 chromium which provide good corrosion resistance properties. However, the corrosion resistance of grade 410 steels can be further enhanced by a series of processes such as hardening, tempering, and polishing. The second is the austenitic stainless steels. The austenitic stainless steels is composed of an austenite face field that is extended to room temperature. Resistant din siya sa corrosion dahil mataas yung chromium content at may dagdag din element na nickel. Their crystalline structure prevents austenitic steels from being hardenable by heat treatment and makes them essentially non-magnetic. For the austenitic stainless steels, we have the grade 304 stainless steel, which is the most commonly specified austenitic stainless steel, accounting for more than half of the stainless steel produced in the world. This grade withstands ordinary corrosion in architecture. This grade withstands ordinary corrosion in architecture, is durable in typical food processing environments, and resists most chemicals. So the third is the ferritic stainless steels. Ferritic stainless steels is composed of the alpha ferrite or the BCC phase. As well as the austenitic, hindi sila heat treatable kaya naman para ma-hardened and ma-strengthened ay ang ginagamit ay cold work. Ferritic steels are high chromium magnetic steels that have a low carbon content. It is also known for their good ductility, resistance to corrosion, and stress corrosion cracking. Ferric steels are commonly used in automotive applications, kitchenware, and industrial equipment. A type of the ferritic stainless steel is the grade 409, which is a titanium stabilized ferritic stainless steel. Nakaka-form siya ng light protective rust layers sa exhaust gas atmospheres. Madali din siya i-weld and suitable din for high temperatures. This grade has the lowest chromium content of all stainless steels and thus is the least expensive. Cast iron. Another type of first alloy ay yung cast iron. It contains less than 2.14 weighted percentage of carbon. Minsan nagko-contain siya between 3.0 to 4.5 weighted percentage ng carbon. Kaya naman it is very brittle. These alloys have relatively low melting points which is 1,150 degrees Celsius to 1,300 degrees Celsius, making them become liquid easily. And nag-undergo din sila ng moderate shrinkage during solidification. Therefore, they can be easily melted and amenable to casting. With its relatively low melting point, good fluidity, castability, excellent machinability, resistance to deformation, and wear resistance, cast irons have become an engineering material with a wide range of applications and are used in pipes, machines, and automotive industry parts such as cylinder heads. The most common cast iron types are gray, nodular or ductile, white, malleable, and compacted graphite, which will be discussed in the next slides. Gray iron. In the gray iron, the carbon contents of gray cast irons vary between 2.5 and 4 weighted percentage. The silicon contents of gray cast irons vary between 1 and 3 weighted percentage. They are very effective in damping vibrational energy. High resistance din sila sa wear, and ito rin yung pinakamura sa mga metallic materials. It is the most common cast iron and the most widely used cast material na naka-based sa weight. It is also used for housings where the stiffness of the components is more important than its tensile strength, such as internal combustion engine, cylinder blocks, pump housings, valve bodies, electrical boxes, and decorative casting. So here, ito po yung pump housings and yung electrical box. So here is the microstructure of a typical gray cast iron. So the graphite exists in the form of flakes and is normally surrounded by an alpha ferrite or pearlite matrix. Because of these graphite flakes, the fractured surfaces takes on a gray appearance. That's why it is called the gray iron. Mechanically, gray iron is comparatively weak and brittle in tension as a consequence of its microstructure. The tips of the graphite flakes are sharp and pointed and may serve as points of stress concentration when an external tensile stress is applied. Ductile iron is a type of cast iron known for its impact and fatigue resistance, elongation, and wear resistance due to the spherical or round graphite structures in the metal. Based sa name, mas ductile ito kaysa sa ibang cast irons. Adding a small amount of magnesium and or cerium to the gray iron before casting produces a distinctly different microstructure and set of mechanical properties. Ductile iron also provides better resistance to corrosion. Ductile iron applications has greater strength and ductility than gray iron. Kaya naman, effective gamitin ang mga ductile iron sa mga industrial applications. So here is the microstructure of a typical ductile or nodular iron. The matrix phase surrounding these particles is either pearlite or ferrite, depending on heat treatment. It is normally pearlite for an cast piece. However, a heat treatment for several hours at about 700 degrees Celsius will yield a ferrite matrix as in this photomicrograph. Ductile iron has mechanical characteristics approaching those of steel. Typical applications for this material include valves, pump bodies, crankshafts, gears, and other automotive and machine components. White iron. The white iron contains less than 1 weighted percentage of silicon. Here, the carbons exist as cementite instead of graphite. A white appearance is formed in the fractured surface of this alloy. That is why it is termed as the white cast iron. White cast irons are used in abrasion-resistant parts where its brittleness is of minimum concern. It is also too brittle for use in many structural components and is not used in machinery purposes. So here we have a nozzle and a ball mill. A ball mill is a form of grinder that is used to blend or grind materials for use. It is a cylindrical device mainly for grinding materials such as iron ores, ceramic raw materials, glass, steel, and etc. The ball mill works on impact and attrition principle. Here we have an optical photomicrograph showing the microstructure of white iron. The thick sections may have only a surface layer of white iron that was chilled during the casting process. The gray iron forms at interior regions which cool more slowly. Generally, white iron is used as an intermediary in the production of yet another cast iron, which is the malleable iron. Its use is limited to applications that necessitate a very hard and wear-resistant surface without a high degree of ductility, for example as rollers in rolling mills. Then we have the malleable iron. In the malleable iron, the heating of white iron causes decomposition of the cementite, therefore forming graphite that exists in the form of clusters or rosettes surrounding by a ferrite or perlite matrix depending on the cooling rate. The heating of the white iron requires temperatures between 800 and 900 degrees Celsius to prevent oxidation. The malleable iron starts out as cast iron, but an annealing heat treatment is applied to the cast iron to make it more workable and increase ductility. However, the malleable iron has much lower carbon content than cast iron. Representative applications include connecting rods, transmission gears, and differential cases for the automotive industry. Here we have an optical photomicrograph showing the microstructure of malleable iron. The microstructure is similar to that for nodular iron, which accounts for relatively high strength and appreciable ductility or malleability. Gray and ductile cast irons are produced in approximately the same amounts. However, white and malleable cast irons are produced in smaller quantities. Last is the compacted graphite iron, a relatively recent addition to the family of cast irons. As with gray, ductile, and malleable irons, carbon exists as graphite, which formation is promoted by the presence of silicon. The silicon content ranges between 1.7 and 3 weighted percentage, whereas the carbon concentration is normally between 3.1 and 4 weighted percentage. Magnesium and or cerium is also added, but concentrations are lower than for ductile iron. The chemistries of the compacted graphite iron are more complex than for the other cast iron types. The compositions of magnesium, cerium, and other additives must be controlled so as to produce a microstructure that consists of the worm-like graphite particles, while at the same time limiting the degree of graphite nodularity and preventing the formation of graphite flakes. Furthermore, depending on heat treatment, the matrix phase will be perlite and or ferrite. The compacted graphite irons are now being used in a number of important applications, which includes the diesel engine blocks, exhaust manifolds, gearbox housings, brake discs for high-speed trains, and flywheels. So here we have the flywheel and a exhaust manifold. So here we have a typical compacted graphite iron microstructure. Microstructurally, the graphite in the compacted graphite iron has a worm-like or vermicular shape. In a sense, this microstructure is intermediate between that of gray iron and ductile iron. In fact, some of the graphite that is less than 20% may be as nodules. However, sharp edges, which is the characteristic of the graphite flakes, should be avoided because the presence of this feature leads to a reduction in fracture and fatigue resistance of the material. Higher thermal conductivity, better resistance to thermal shock, and lower oxidation at elevated temperature.